Okay, so our question is, how does changing mass affect the velocity of the gray cart after a collision, assuming conservation of momentum?
The objective is to find the relationship between altering mass and final velocity of the cart. So in our experimental design, our materials were the motion sensing cart, which is this one right here, our gray cart right here, the track, the barrier, and weights. Everything in this experiment, we know the weight of it. So first, the masses of the carts and the weights are known. The mass of the gray cart was altered by attaching weights. The weight is right here. This weight changed the momentum of the cart, which would affect the gray cart's initial velocity that we're going to find. The independent variable we have is weight, the dependent is the initial velocity of the gray cart, and the controlled variable is the push force on the gray cart.
Okay, for our procedure, the first thing we did is we set up the two carts on the track, a motion sensing one that was blue and then a gray one, and we made sure that the track was level. Second, we used different attachments on the carts for our different types of collisions. So for the elastic collision, the motion sensing cart was at rest as we pushed the gray cart into it with the bumper in between them so that they would bounce off of each other once they collided. For the totally inelastic collision, we repeated the same procedure as step 3, except there was a Velcro in between the carts, so when they were pushed together, they stuck together. And for the partially elastic collision, we again repeated the procedure in part 3, except there was a piece of cardboard in between the carts. And for each collision, we did 4 trials and increased the mass on each trial. And lastly, we made sure to push with a constant force in every trial, which was also our controlled variable.
After collecting our data using Vernier graphical analysis, we put it into this chart. Here we have elastic, partially elastic, and inelastic. And we have which trial, how many weights we added, and the velocities. We found the final velocity of the green cart, and we knew that it started from rest. Using this, we could find the velocity initial of the gray cart using this equation down here, which was in our notes, and is also derived by combining and replacing different variables in both a momentum and energy equation. Using that, we got our velocity initial of the gray cart. Then using this equation right here, using conservation of momentum, we found the velocity final of the gray cart. Down here, we just brought over the final velocity of the green cart for the gray cart because we know that they stick together. So using these values, we have a graph for our inelastic collision. We have change in velocity on the bottom and weight on the y-axis. This right here is for elastic, with change in velocity on the y-axis, on the x-axis, and weight on the y-axis. We notice that both of these decrease. This means that as weight increases, the change in velocity of the gray cart decreases, showing that since it has more momentum in the beginning, it loses less of it. Sources of error in our experiment can be either the collision itself, because elastic collisions are impossible in the real world, or because the collisions are not instantaneous, so friction acts while the collision is taking place. Both of these would mean that there is an external force which removes momentum from our system, and that would result in a lower change in velocity. This would make our graphs less steep, but the general trend would stay the same.
In our experiment, we noticed a consistent trend in that as we increased the mass of the gray cart, the change in velocity of that cart decreased. As we continued to add mass to the gray cart while keeping the green cart's mass constant, the change in the gray cart's velocity became smaller and smaller. To put this into perspective, we can think about a car crash involving 2 cars, one of a larger mass and a smaller mass. A larger car, due to its larger mass, typically experiences less change in velocity in a collision. This makes the impact feel less severe in comparison to the occupants of the smaller car. The same principle can apply to the gray cart in this experiment.